Oh, I wanted to make that. Okay. So I wanted to make my great joke about, the Nobel Prize of yesterday inspired Ellen and me to work on this paper. But that'd be a little bit.
You can go ahead and do that speech, but we are just already recording, so just bear that in mind. And without further ado, Simon Loertscher is going to talk about efficiency wage theory revisited. Simon, the floor is yours.
Yeah, okay. Thanks a lot for having me. I'm very excited to present the paper. I haven't presented it for a month, and it's evolved a lot. Now the paper is again ahead of the talk, but I've just finished updating the talk, so hopefully that's going to go well. This is joint work with Ellen Muir, who's finishing up her PhD at Stanford. What more should I say? Yeah, so here we go. I give a somewhat unorthodox way into the paper by just saying what we do in the paper rather than giving a broad motivation. So we see how that goes. So this paper provides a model in which monopsony employers' optimal procurement mechanism involves involuntary unemployment and an efficiency wage that involves wage dispersion, or that induces wage dispersion, because the efficiency wage is set above the market clearing wage, thereby inducing involuntary unemployment. The mechanism, or this procurement mechanism, is optimal for the monopsony in the sense that it minimizes procurement costs, subject only to the IC and RER constraints of the workers. So the assumption here is that the workers are going to be privately informed about their opportunity cost of working. And so in some sense, or in that sense, the mechanism resonates, I think, with the dictum often attributed to Henry Ford, that the $5 day that they introduced in 1914 was the greatest cost saving they've ever had. If you then think about, so we get, without any free market equilibrium, so to speak, we get involuntary unemployment, right? So then the question is, well, what are the effects of introducing a minimum wage? And so there's going to be a wage dispersion, as mentioned, in the unregulated equilibrium. Now, what happens if you set a minimum wage equal to the lower of these wages, or increase it slightly above that? That's going to have a positive employment effect. So you have involuntary unemployment, you impose a minimum wage, and that's going to increase total employment. At the same time, it's going to decrease involuntary unemployment. And we're going to show that it may even be possible that through an appropriately chosen minimum wage, you both increase employment and get completely rid of involuntary unemployment. So that's a possibility within that setup. This is one of the slides I hadn't had the time to update the summary of the quantity competition model. So the question then is, how do these effects extend or depend on the monopsony assumption? Do they extend to a competitive model? So we introduce a new model of quantity competition in which, rather than procuring the aggregate quantity demanded by the firms at the market clearing wage, it's going to be procured at the minimum procurement cost. One of the things we show there is that there's no relationship between the intensity of competition and whether or not you have involuntary unemployment. And indeed, it's possible for employment to increase with competition. That will always be the case. Aggregate employment increases with competition, but at the same time, competition may induce involuntary unemployment. And indeed, it is possible in that model to have perfect competition and involuntary unemployment in equilibrium. Let me maybe just speak to the last item here on that slide. Then, if we allow for a hoteling model where you have a multi-product or multi-jobs firm, then on top of involuntary unemployment, it may be optimal for the firm, the multi-product or multi-jobs firm to mismatch workers to jobs, or to have jobs rotation amongst a subset of workers that is inefficient but reduces its procurement cost. Okay, so let me give you, this is the overview of the rest of the talk. So talk about the setup shortly, and the monopsony optimal mechanism, talk about the minimum wage effects in that setup. Then we talk about quantity competition, time permitting. I'll be talking about the multi-jobs monopsony and some effects of banning minimum wages. You know, my main goal of the talk is to convince you that all these effects that I just claimed are not only true, but also actually quite intuitive and kind of make perfect sense once you see the mechanics of it. And next, I give you a short summary of the related literature. And just ask questions. I don't see all of you, and I have difficulties following the chats. Okay, so there's three broad strands of literature. This paper relates to, of course, the long-lasting interest in efficiency wage theory, which some attribute, or which can be attributed, I think, the origins of which can be attributed to Engels and Marx's idea of a reserve army of the reserve army of the unemployed, that somehow in the benefit of the capitalists. And we'll have a model where this is actually going to be the case, right? So it's actually there is going to be a reserve army of the unemployed that benefits the firm. You know, some in a more recent disguise, this idea that unemployment is in the benefit of, can be in the benefit of firms has taken particularly has been taken up following as the motivation by the Henry Ford experiment of increasing wages for the workers, which induced involuntary unemployment. That has been primarily analyzed in principal agent models, where somehow the unemployment serves as a disciplining device for the workers. You know, as Janet Yellen summarized it, all these principal agent models suffered from a similar theoretical difficulty, which is that more complicated contracts, so without restricting the contracting space, you can reduce or eliminate involuntary unemployment. So that's one strand of literature we're relating to. In our model, this is not going to be an issue because there's just not going to be any effort. So this is just a pure, what people call adverse selection model or selection model. Yes, speaking of which, there's a long tradition in monopoly and monopsony, oligopsony pricing, that minimum wages can have positive employment effects as long been recognized. So George Stiegler's 46 AER paper, which to our knowledge is the first that made that point. Just similarly to for monopoly pricing, if you impose a price cap, that can have a pro-competitive effect, can induce the quantity traded because of quantity produced, or in the monopsony model, quantity employed, because on the inframarginal unit, the firm with market power becomes a price taker, and so becomes more, behaves more pro-competitive. But these models do not have the effect that you have in involuntary unemployment in equilibrium. And last but not least, our paper also relates to mechanism design and monopoly pricing problems without regularity, that is where the objective functions are not necessarily well behaved, not necessarily concave, the optimization problem. And so the first one to introduce that, to have analyzed the monopoly problem with non-decreasing margin revenue was Hotelling, and ours. We're basically looking here at the flip side of our monopoly pricing model, but what we add to that is the minimum wage analysis or wage regulation, price regulation analysis, and competition.
Hey, Simon, can I ask a question that at least to me seems appropriate now. So when you say regularity, my understanding is that, in the traditional sense, regularity is just an assumption that, on the distribution of types that allows you to solve things very easily, right? So in a sense, should I look at this paper as, we're going to see what's going on without regularity, and then we're going to apply it to efficiency wage theory? Or is there anything that is not just a generalization in the way you treat regularity? So is it anything in the economic problem that you want to analyze that requires considering non-regular objective functions?
Yes, that I didn't highlight that before, because that's driving the non-regularity is the driver of in long-term employment here. I didn't highlight that in the summary. I just take that as part of the model.
I see. Okay, cool. Cool. Thanks.
Okay, setup. So it's a very standard monopoly or monopsony pricing setup in the following sense. So it's going to be a continuum of workers, each of which has his or her own idiosyncratic opportunity cost of working, and we're going to summarize that by an inverse supply function W of Q, which gives you the market clearing wage to hire Q workers. And we're going to assume that W of Q is an increasing function in Q. And each worker supplies 1 unit of labor inelastically. Okay. And each worker is privately informed about his or her opportunity cost of working. W of Q is strictly increasing and continuously differentiable, sorry. And so the key element of the analysis is this procurement cost function C of Q, which is just the cost of procuring Q units of labor at the market clearing wage W of Q. So it's not fancy. I'm not claiming any deep math here, but if you take the derivative of C, you get the marginal cost of procurement, right? And this is given by applying the product rule. You get that this is this function here. And because W is increasing, W prime is positive. And so for any positive quantity, the marginal cost of procurement is larger than W of Q. This is not deep or new, right? This is the very reason why, say, Stiegler found this pro-competitive effect of imposing minimum wages, because the firm with market power is gonna take into account its effect by increasing quantity demanded, it's gonna raise the price. So that's the very reason why you get inefficient levels of employment with market power. But I just want you to bear that in mind, because it's gonna come back and play a key role in some of the results. Okay, and what else do we impose? Well, there's going to be willingness to pay of the monopsony for Q units of labor, which we summarize by V of Q. And for simplicity, for almost all of the analysis, we're going to assume that this is a strictly decreasing function of Q and the continuous function. And the strictly decreasing nature is just to avoid multiplicity of optimal quantities. It doesn't play any other role. And if you allow that to have some flat parts, for most of only in one knife edge case, it will play a role. Okay. Yes, we're assuming that it's optimal to employ some workers under market clearing wages, but you wouldn't be employing all the workers under market clearing wages. And we're going to say that the monopsony uses an efficiency wage. If it hires, when hiring Q workers, it sets a wage W2 that is above the market clearing wage and hires a positive number of workers at that, or positive mass of workers at that high wage. Okay, so far so good. It's a very standard setting.
Sorry, Simon, very stupid question about the notation. Maybe I missed something. Why W2 and not W1 or W in the definition you just gave?
Per se, that doesn't play a role, right? That notation, sorry. We're going to use that notation. We're going to have, it's going to be optimal to either use one wage or two wages. And so we're going to use W2 for the high wage and W1 for the low wage if you use two wages. So at this point, that notation doesn't play a role. It doesn't make sense, but it will temporarily. Okay, so let's look at the optimal procurement mechanism and when that induces efficiency wages or involves efficiency wages and involuntary unemployment. Okay, so I think so far everything I did is a reasonably standard, almost textbook monopsony setting. The only thing we didn't do here was impose curvature assumption on C. Right? We didn't say we're assuming that the procurement cost is a convex function, and kind of a standard, and as you will see, it's kind of a twin assumption. Standard assumption in the literature is to either impose market clearing wages, or which is going to be equivalent to that in some sense, to assume that C is a convex function. And these are twin assumptions in the sense, or it's one assumption in the sense that if C is a convex function, then using market clearing wages is going to be optimal. So we're going to not require C to be convex, so we're not going to be restrictive in that sense. And so what I would like to say, each time you drop these assumptions, like in monopoly pricing, you do not require revenue to be concave. You get some sort of pushback as to why are you departing from that assumption. We'd just like to highlight that dropping that assumption is less restrictive than imposing it, right? So this is more general rather than less general. And I don't think our reviewer at the ARC is part of the audience here, but in case you are, this is less restrictive than imposing convexity of the cost of procurement function. Okay, so still you might ask, well, why should C not be convex? Well, we might ask back, well, why should it, right? But what's the theoretical reason or any other reason for it to be convex? In comparing it to the monopoly pricing problem, I haven't seen much studies in the labor markets as to whether or not these functions are convex, but the analog to that, as mentioned in the monopoly pricing problem, would be that the revenue function is concave, which is the standard assumption in both theoretical and empirical work. But empirically, when it is not imposed, regularity that is decreasing marginal revenue, which is equivalent to concave revenue functions, is often rejected. So we have lots of references on that in the precursor to this paper here. One reason, if you want to look for a micro foundation for why you may have non-convex cost of procurement functions under market clearing wages, is there's a fixed cost of labor market participation or a fixed cost of moving into a given labor market. And so at that, once you get people coming into that market, the function will become, at that point, will become non-convex. We'll have a kink.
So Simon, just a stupid question, just to fix ideas. So this is done for the sake of generality, or when the function is going to be convex and the results are not going to be interesting?
Well, as I said, so they're going to be much less interesting, right? If the function is not convex, if the function is convex, then as you will see, market clearing wage is going to be optimal, and you don't get involuntary unemployment and efficiency wages. So this is not just, it's not for the sake of generality. It is the case that our result hinge on non-convexity. Okay, now maybe I could give the floor to Anton, because now we're going to talk about the convexification of a non-convex function. And when I presented previous versions of this or of the other paper, somebody in the audience said, "Oh, this is interesting to see that this is not just used in information design, but can also be used in mechanism design." To which my reaction was a little bit, well, yeah, but that was done in 1931 already. So it's kind of it's a reverse history, right? Anyway, okay, so we're looking at the convexification of the function c, which we're going to denote by c lower bar. That's going to be the largest convex function that is nowhere above c. And maybe I can just, if my camera works, just stop sharing for a second. Yes. Okay, so let me try to show how that under this, if the function c is smooth as we assume, how you can do this convexification. So and this is easy to draw for a general function rather than a cost function for reasons that will become clear shortly. So suppose you have some function c of q that's not convex, as is pretty clear here from the picture. So the way you can find its convexification, it's conceptually, it's very simple, right? You're going to find this function here that has the same, this linear function or linear extension here, the dashed line, has the same slope as c at some q1 and the same slope as c at some q2. So the way you convexify this is you find the q1 and the q2 such that these marginal slopes are the same, right? And the average slope over this range here has to be the same. So it also has to be the case that c prime of q1 is equal to c of q2 minus c of q1 divided by q2 minus q1. So it's these two conditions that you use to find this function here. And so then the convexified version of this function here will be this one here. It agrees with the original function outside that q1, q2 interval, and it's equal to that linear combination in between. Oh, and what I should say here, why is this easier to draw? This is still a convex function, right? But it cannot happen that the cost of procurement function has this form here, because you cannot have an array that goes through it twice from the origin a straight line. That's why I prefer to draw that on paper for a general function rather than having it on the slides, where one would then have to, one either has to have a very narrow function, and that makes it very hard to see what's going on. Okay, and so what we have here on this slide here is just a more general definition of that, more general in the sense that we do not just restrict attention to the possibility that there's only one so-called ironing interval or interval of non-convexity. So we're going to index these different intervals by m, and the set of all these subintervals is denoted by script m.
Salman.
Yep.
Given the whole discussion on convexity that you had a minute ago, is there no condition on the second derivative of c that you need?
In what I just did?
Yeah.
Yes, very good. At least at the points q1 and q2, c double prime will be positive. Right? That has to be the case for optimality. So c double prime of q1 is positive, and c double prime of q2 is positive.
But there's nothing that looks like super contact or anything like that.
Looks like, sorry?
Super contact. So the derivatives, the second derivatives on the other side of those points have to be the same.
No, not the second derivatives can't be the same. Right? If the first derivatives are the same, the second can't be, because w of q2 will be larger than w of q1, and that means that something about the the second derivative. It's the first derivatives that have to be the same.
Okay, thanks.
Okay, and here would be this, I've been looking at that example so much that even if I see shadows outside in our backyard, they remind me of this kinked supply function. So this here would be a piecewise linear supply function that is non-convex and that induces a non-convex cost of procurement function. So this on the right-hand side, we have the cost of procurement function. Here we have the inverse supply function. Okay, and if you then zero in on that kind of ironing interval, this is what the red function here is, the iron or the convexified version of it. This here would be the original marginal cost of procurement function, and this here is then the kind of ironed or convexified cost of procurement function. It becomes flat in that part here. Okay, now okay, so it's very nice, right? But what's the whole point of this? Well, the interesting part is that C of Q lower bar, right, this convexified cost of procurement function is the minimum cost for procuring a quantity Q. Right, and then if you have, if it happens that V, the willingness to pay function, intersects with the C lower bar prime function in that iron part, so that you have a Q star in here, right, that first sort condition is satisfied here, then the optimal procurement mechanism will involve, it's to be shown, right, but then the optimal procurement mechanism will involve involuntary unemployment and an efficiency wage. Okay, now, okay, how can we show that the minimum cost for procuring the quantity Q is C lower bar? Well, let me walk you through parts of the argument. So I think the surprising part is that you can procure at C lower bar of Q, that you can attain that. So I'm going to walk you through that. The fact that you can't do better requires a little bit more work, and that's going back to Meyerson's arguments. So I'll leave that aside, but I'm going to show that you can procure the quantity Q at the cost C lower bar of Q. And yeah, as I said, an efficiency wage and involuntary unemployment is going to be optimal or part of the optimal mechanism if and only if C lower bar of Q star is less than C of Q star. Okay, now the proof that you can achieve C lower bar of Q is pretty easy if C lower bar of Q is equal to Q, because then you could just procure at the market clearing wage, right? So okay, that part is done. So the more difficult part is when C lower bar of Q is strictly less than C of Q. Yeah, here we're just going to focus on one such ironing range. Therefore, we're going to drop the index script on Q1 and Q2 that was M. And so now here is going to go back to Antonio's question. What's the role of these W1s and W2s? Suppose the monopsony uses two wages, W1 and W2, where W1 is a small wage. And it's going to set the small wage W1 such that it hires Q1 workers less than Q at that wage. And it's going to hire the additional Q minus Q1 workers at the wage W2. So if you're working at, if you stand the Q to work at the low wage, you're going to be hired for sure. There's not going to be any excess demand. Whereas if you're standing the Q to get hired at the high wage, W2, there's going to be excess supply to the extent that there's Q2 minus Q1 workers competing for Q minus Q1 jobs. So the probability of being hired at the high wage is going to be this number alpha, this fraction Q minus Q1 divided by Q2 minus Q1. To make things simpler, we're not going to denote the dependency of alpha on Q, but alpha is increasing in Q. The probability of being hired at a high wage is going to be an increasing function of the quantity that the monopsony procures. Okay, and so the equilibrium construction is such that workers with opportunity cost of working between W of Q1 and W of Q2, they're gonna try to work at the wage W2. Okay, so the participation constraints for the marginal worker to participate in that is that the wage W2 be equal to the market clearing wage of these workers. So little W2 is equal to the market clearing wage for Q2. Remember that Q2 is larger than Q. Now, there's an incentive compatibility constraint for workers with a willingness to pay or opportunity cost of working of W of Q1. They need to be indifferent between working at the low wage W1 and participating in the lottery where they have a chance of alpha of being hired. So this indifference condition is what's the first equation spelling out in this display here. If you solve this here for W1, then you get a function W1, which this is going to be the low wage that the monopsony sets, which is just a convex combination of W of Q1 and W of Q2 with weight alpha on W of Q2. Yes, notice that W2 does not depend on Q as long as Q is inside that interval, whereas W1 is an increasing function of Q just because alpha is increasing. And also, as an aside, if you take the derivative here with respect to W of Q1, the derivative on the left-hand side is -1, and the derivative on the right-hand side is minus alpha. As long as alpha is strictly less than 1, the derivatives are different, and you have single crossing, right? So that means that if the worker with a willingness to pay of W of Q1 is indifferent, then all the other workers are either strictly better off participating in the lottery or working at the wage W1. Okay, so now we construct an equilibrium such that you can procure these quantities at the costs. At wages W1 and W2, and now we need to show that you actually achieve C lower bar of Q. So the wage payment that you make to the low wage workers is Q1 times W1, which is this number here, and the total wage bill for the high wage workers is this here. If you add these things together, you get indeed C lower bar of Q. So that completes the proof that you can, even if C lower bar of Q is less than C of Q, you can achieve C lower bar of Q in equilibrium. Okay, so I think there's a clear, although somewhat unknown or too little known intuition for why this works. What the monopsony would like to do is it would like to hire the Q workers at the lowest marginal cost, right? That gives you the lowest cost of procurement. But if C is not convex, then C prime is not monotone, and so that means that hiring the Q workers with the lowest marginal cost is not the same as hiring the Q workers with the lowest cost, right? So marginal cost and the ordering of marginal costs and costs differs. But then 1 and 2 conflict with incentive compatibility, where incentive compatibility says that you cannot hire a worker with a lower cost, with lower probability than you hire a worker with a higher cost. It's very straightforward property of incentive compatibility. And so then the best you can do is you hire them with equal probability. And that's exactly what the efficiency wage and the involuntary unemployment achieve. Right? They equalize these probabilities and sort of iron out these wiggles. So the reserve army of the unemployed here is used to as a device to hire low cost but high marginal cost workers with equal probability as high cost but low marginal cost workers. And so that's what you achieve through this efficiency wage and involuntary unemployment scheme. Okay, now let me talk a little bit about the minimum wages, right? It customarily or commonly perceived as sources of unemployment, right? If you look at competitive models with price-taking firms, then a minimum wage is either ineffective or induces involuntary unemployment. In our setting, as mentioned, we get involuntary unemployment without the minimum wage, and now it's interesting to see what happens when you have a minimum wage. So, as mentioned, we're going to show that it can not only increase total employment as you would have in, say, George Steger's setting, but it can also be used to reduce involuntary employment and possibly eliminate it. So the problem with that, and this is the first time I present this because this is since the last rendition. This is the insights that have been added. We first need to solve the procurement cost minimization problem when you face a given minimum wage, W lower bar. And so let me walk you through the steps involved in that. Okay, so this should be a lowercase W lower bar. So we're going to denote the minimum cost of procuring quantity Q given the minimum wage W lower bar by C lower bar of Q and W lower bar. Some cases are rather straightforward, right? If S here, big S, denotes the quantity supplied at a given wage. If you want to procure a quantity that's less than the market clearing wage, that's less than the quantity supplied at the minimum wage, then the best you can do is you just hire these Q units at the minimum wage. So that case is simple. Also, if the quantity you want to procure is not inside an ironing interval, and you want to procure more than the market clearing, more than the quantity, more than S of W lower bar, then you can just hire, or the minimum cost of procuring the quantity is C lower bar of Q. Yes, that is not quite right. So sorry, the condition here is not quite right. It should be S of W lower bar is not inside that ironing interval. So what I want to say, if W lower bar is neither between, that's the gist of it. If W lower bar is neither between the lowest wage that you would be setting in equilibrium and the highest wage you would be setting in equilibrium, then W lower bar is not going to play a big role, or it's not going to play a role, and you just can procure the quantity Q at C lower bar of Q. Okay, yeah, so that's in essence what I'm trying to drive home here at the towards the bottom of that slide. So the difficult cases to consider, or the non-trivial cases to consider, are those where you want to procure a quantity Q that's inside an ironing interval. That's summarized here. And W lower bar is larger than the lowest wage you would be setting in the unregulated equilibrium when you buy the quantity Q. Okay, and so because W1 is increasing in Q, this condition is equivalent to Q being less than W1 inverse of W lower bar. Okay, and so the solution to this, or let L star be the solution value of the Lagrangian associated with this problem here. What is this problem? Well, you're convexifying this function here. So you find the optimal two-wage mechanism for this problem here, where the constraint is that the lower wage that you're going to set must not exceed W lower bar. And I'm using lowercase q1s and q2s here to say that these are the choice variables that you have in this constraint optimization problem. And so in that range where W lower bar binds, this is the statement here, the minimum cost of procurement is going to be given by the solution value of the Lagrangian, of this Lagrangian here. So from a mechanism design perspective, what is difficult to show and requires a fair bit of work is showing that it is without loss of generality to look at these two-wage mechanisms. And this is a little bit different from standard constraints that are imposed on mechanism design problems, where the constraints are typically imposed on quantities. Here the constraint is in price-based, and so that was a little, that required a bit of work. Okay, so, but what do we learn from that solution? What can we say about the solution? Interestingly, we can say a fair bit. Maybe the most interesting parts here are those in the display here. So the first one says the marginal cost of procurement in that iron range is going to be increasing. So if you look at the picture, the red one would be the procurement cost function or marginal procurement cost function without the wage constraint, and the blue one is the one with the minimum wage constraint. And what we get is that in the range where you still do non-trivial ironing, this function will be increasing rather than flat. So that's the point I want to drive home about this here. And that comes from the fact that as you're increasing the quantity, the Lagrange multiplier associated with the constraint decreases. So you got something else moving, and that's what drives that result. And then the cross effect is if you increase the marginal, if you increase the minimum wage, the marginal cost of procurement will decrease, which is at the heart of the quantity increasing effect of minimum wages. And then the last bit here is if you denote by Q1 star and Q2 star the ends of the ironing range given a minimum wage. So these ranges are going to move closer and closer together towards Q actually as W lower bar increases. The tighter is the constraint, the smaller in a set inclusion sense is the ironing interval. Okay, and so that then allows us to state these results. So what are the equilibrium effects of imposing a minimum wage? Suppose without the minimum wage, Q star is in an ironing interval. Otherwise, it's just, these are the standard results. So then if you look at the minimum wage between W1 and the efficiency wage that would be obtained without wage regulation, if you then increase W lower bar, total employment is going to increase. Involuntary unemployment decreases. The total wages paid increase. Wage dispersion measured as the difference between the highest and the lowest wage in equilibrium decreases. And last but not least, under this condition here, the minimum wage equal to W of Q2 is going to completely eliminate involuntary unemployment. Maybe a different way of saying that this wage dispersion decreases is actually the lowest wage increases and the highest wage decreases with the minimum wage. Yeah, I need to be a little bit more precise about that in a second. All right, let me just give you the intuition for why we get this possibility of eliminating involuntary unemployment completely with a minimum wage equal to W of Q2. So the blue dashed line here is the iron marginal cost curve. This is the without wage regulation. This is the same in both pictures. And the red function here, the flat line, is W of Q2. And remember my speech at the beginning when I introduced the C function and I said C prime of Q is larger than W of Q. Well, this dashed line here is C prime of Q2, and that is larger than W of Q2. So that means that this red function has to be below the flat part of the iron function. Okay, so this is the this is a minimum wage equal to W of Q2. And if you have a decreasing V function, then that point of intersection is going to occur to the right of Q star. So that's the positive employment effect that you get. And then the question is, in the left-hand panel, that point of intersection still occurs within the ironing interval. So you would still have, you would not be procuring Q2 units of labor. Whereas in the right-hand picture, that point of intersection occurs to the right of Q2. So you optimally procure exactly Q2 units at a minimum wage equal to W of Q2. Okay, you will not procure more here in the right-hand panel, right? Because for any additional units above and beyond Q2, your marginal cost of procurement is then again given by the blue function. That's above your willingness to pay. Okay, so I am left with 10 minutes, which I can spend on, well, maybe you can walk through that. At least I can give you the gist of the quantity competition model. All right, so how do these things extend, or to what extent can we extend these insights to a model of competition? Well, we propose a model of quantity competition in which there's n symmetric firms, each of whom has the same willingness to pay function B, which is a decreasing function of its own quantity, little qi. And the firms are going to choose these quantities qi simultaneously, submit them to a Kurner-Walrasian auctioneer who aggregates this quantity, and then rather than procuring it at the market clearing wage, procures it at the minimum cost, C lower bar of Q. Okay, how is that cost going to be allocated to the firms? Well, if the aggregate quantity is Q and firm I procures QI units, firm I is going to pay little QI divided by Q, the share, its market share, as a times the total procurement cost. And notice that this is exactly as you would have it in standard quantity or Kurner competition, where you just have to replace C lower bar by C of Q, and then you see that firm I would be paying QI times W of Q. So it's exactly in the Kurner spirit, except that we don't impose market clearing wages. Okay, so what are sort of some of the key insights of that Kurner model? So if we denote by Q and P the quantity or the efficient quantity that would be procured if firms were price takers, then Q and P satisfies this condition here. Right? That's the efficient quantity to or employment level for a given end on the price taking behavior. If you look at the standard Kurner symmetric equilibrium on the Kurner competition, then and if such an equilibrium exists, then the equilibrium condition is this here. And because the right-hand side involves this W prime, which is positive, it's straightforward to conclude that the Kurner equilibrium quantity is less than the price-taking quantity Q and P for a given n. Okay. In our model, if we impose symmetry, which we don't have to suppose, sorry, I should say, formulate this differently. In our model, there's going to be a unique equilibrium, and this equilibrium is going to be symmetric. So full stop. And so the symmetric equilibrium condition is this one here. which is a convex combination of the marginal cost of procurement, C lower bar prime, and the average cost of procurement, C lower bar divided by Q. And if Q star is within an ironing interval, then we know that C lower bar is less than C of Q. Therefore, C lower bar divided by Q is less than W of Q. So that means that it can be in our model that the perceived marginal cost of procurement for a firm under competition, at least if N is large enough, is less than the market clearing wage for that. What that means is that it is possible in this model here to get excessive employment with competition. And to give you a sense of what that looks like, what I've drawn here is our kinked inverse supply function, W of Q, and then the red curves here that decrease, that come down, are the right-hand side of this first order condition as you increase N. And so as you increase N, this function here shifts to the right. And this here is for, I think, N equal to 15 for that specification. This is the right-hand side as a function of Q for N equal to 15. And if this here is V of Q divided by N, the point of intersection with the wage function occurs here. So that gives you the efficient quantity, and the Coulomb equilibrium quantity is then larger in this case. So that's sort of one of the problems or issues that arise in this model here. What we can show is that the equilibrium quantity always increases in N. There is a symmetric and unique equilibrium in this model. That basically follows from the convexity of the C function. And then if you take the limit, so you can get that reversal of excessive equilibrium employment only if N is sufficiently large. So you can't get it in the monopsony model. And then in the limit, as you let N go towards infinity, you may or may not have the efficient quantity employed. If you do not have the efficient quantity employed in the limit, then that means that in the limit you still have involuntary unemployment. Okay, so in the interest of time, I think I'm just going to skip the rest here. There's now also some analysis with minimum wages, but I don't have time to walk you through that. So let me just mention the extension to, which I think is quite fun, but also insightful, the extension to a multi-jobs monopsony. So consider a hoteling model, right? You have a firm, a big employer that has jobs at 0 and at 1. Workers are uniformly distributed on 0, 1, and they have linear transportation cost that is normalized to 1 per unit travel. And at each location, the firm is going to have this decreasing willingness to pay function V of Q. And so a worker who works at 0 and has a location X gets W naught minus X as a net payoff. And if the same worker works at 1 and gets a wage of W1, that will be its payoff. Notice that with this payoff function, if you are equally likely, you don't know where you're going to work, but you're equally likely to work at 0 and at 1, your expected transportation cost will be 1/2, right? So if I somehow keep you in the dark as to where you're going to work, or you're going to work half time at 0 and half time at 1, your expected transportation cost will be 1/2, irrespective of your location. Okay, so that's what I wanted to get rid of before we did this. Okay, so let me now walk you through the short and long of the optimal mechanism in this setting. So this function here is just this first solid and then dashed is just 2 times Q, which would be the marginal cost of procurement on the market clearing wages, right? Each worker, if you post a market clearing wage, you're going to pay Q. If you hire Q workers at the market clearing wage, you pay Q per worker. So your cost of procurement is Q squared. So the derivative is 2 times Q. So that gives you this function here. But alternatively, as just mentioned, if I had, I'm a multi-product or multi-jobs monopsony, so rather than hiring you for sure at 0, I can hire you and say, oh, you're going to be equally likely to hire at 0, to work at 0 as at 1, or I can do job rotation or job sharing, right? In that case, you're willing, what I have to pay you to satisfy your IR constraint is 1/2, right? So the marginal cost of hiring people into these uncertain jobs is 1/2. And so 2 times Q is equal to 1/2 at Q equal to 1/4. From 1/4 onwards, the best I can do is mismatch with equal probability workers from the middle, and I'm going to mismatch them to jobs 0 and jobs 1. And so the optimized procurement cost is this solid line here. And so if this here is the V of the red one is the V of Q function, if I were required to set market clearing wages, I would be procuring this quantity here. But without market clearing wages, if I can have that randomization for agents in the middle, I would be procuring a larger quantity, which is this one here. And so here in this specification, on top of involuntary unemployment, which you still get in a kind of a weak sense, you get a positive mass of workers who would like to work at the equilibrium wages but can't, or who would be willing to work, I should say. And you get, on top of this involuntary unemployment, you get worker-job mismatches. And just give me a minute to wrap this up. What happens if you ban wage discrimination, right? You saw from this picture here that allowing for these different wages, I should have said you pay a wage of 1/4 to workers that are close to you and the wage of 1/2 to the workers who are going to participate in these rotation jobs. So there's wage discrimination involved in this scheme as well. There's a weakly positive effect of allowing for wage discrimination because weakly positive quantity effect. But what happens if you ban wage discrimination? Well, there's going to be this weakly negative quantity effect. It's going to improve the welfare of all workers, and strictly so for all the workers who are employed after the wage discrimination has been banned. And it may or may not increase social surplus. So this here is a situation where that's the only case where I assume that V is flat. So if the firm has a constant marginal willingness to pay per workers, this here would be the social surplus gain of having wage discrimination. And this is the additional cost of having wage discrimination. So in this case here, if you ban wage discrimination, social surplus increases. Whereas here, wage discrimination has a positive social surplus effect. But again, it's going to harm workers. And by the same token, I think it's a nice feature of that model is that you get the possibility of, if you think about mergers, of social surplus increasing mergers without any restrictions on quantity, on contracting space, etc. So that's kind of a neat side product.
So Simon, just before you go, so what do you mean here by wage discrimination?
Yes, so in all these schemes here, workers up to 1/4, they're going to keep.
Okay, so in this case, workers, the only difference is location, and if you don't consider location into account, workers should get the same salary. If not,
so the firm offers 2 wages, right? One is 1/4,
yeah.
And workers that are close to 0 and 1 are going to work at that wage for sure, and they're going to know they work at 0 or at 1. These are the specialists. And then there's universalists that, you can be hired to be a universalist. You have to do both jobs.
Okay.
And then your wage will be 1/2. So there's 2 different wages that are paid in equilibrium.
Okay, so my point is that wage discrimination doesn't seem to be capturing what goes on here, right? It's just a matter of the phrasing that you're choosing to use. That's all.
Okay, so I mean,
It has sort of a negative a connotation, right? So you and I do the exact same job. We are the exact, we have the exact same abilities, and for some reason you get a higher wage than I, and I'm discriminated against. But here, workers in a sense are doing different things, right? So one is, if you want, the specialist, and the other one is the generalist, right?
okay, I see. So
it's a minor point. I mean, I was just...
Yeah, no, I hadn't thought about it this way. So in the kind of the homogeneous model of the monopsony model that we looked at mainly, or the quantity competition model, there you have what you would call wage discrimination, because all these workers do the same job, but some are paid more than others. So there you would agree that this is wage discrimination. Here you say there are different jobs, and workers are paid differently, which is not necessarily wage discrimination. Okay, point taken. I'll think about how to frame that appropriately. Okay, so let me conclude here. My favorite picture. Yeah. So this is in this approach here, or from this perspective, right? We get randomization by design. There's somebody who wants inefficient matchings of workers. And I think a deep and open question is, to what extent is randomization that is observed in the real world driven by design, and to what extent is it driven by frictions, search frictions or so. And it has very different policy implications. Right? If it's driven by design, then trying to fight search frictions is probably going to be a little bit of a cat and mouse game.
Let me stop recording. Let me first thank Simon for the presentation, and then let me stop recording.